So, good morning, everyone. Respected sir, this is Ayush from the Innovation Institute of Technology, Agartala, and we are posing our solution on the problem statement number 13, that is cross-modal satellite image travel using multi-sensor remote sensing. So, we have designed a web page using AI/ML data science and all things front end and heavy UI UX design that is based on our the problem statement. So, I just going to explain you that what does the problem statement says and what's our solution. So, our problem statement says that we have the main problem that in the fragmented satellite data across the sensor, that as we know that we have multiple sensor like SAR, optical, multispectral, and then that this sensor gives us the data and the images in the various forms that is not as usually used by the human beings and as a normal user. So we have designing a web page that is named as the prism, where the user can keep a single input of the image and the data of any locality area, and they will get the direct data and the image of the various satellite sensors, so that he can enable us that how the and what's the temperature, what's the locality there, and what's the location, what's the altitude, and another thing is present at there. So our solution have these types of the and coming to our USP of the solution. So first of it's kind of cross-modal intelligence, sensor and linguistic retrieval, AI representation learning, and real-time large scale. And it is easily accessible as a web page to a common user. Now coming to the features to our solution. The first is the multispectral data fusion. So we have the multispectral data from the various sensors. So we combine these toolkit and fix it into the AI, and we have trained our model so that from this sensor the data image can be obtained, can be categorized and check the similarity between them. And after that, the AI analyzing and promising and training the data, we have put it into the intelligence retrieval, that is FAISS, that is check that the similarity between the images. And after that, they will give the solution in the web page and also along with the examples. So let us see that workflow example. Let us user upload an SAR image on our web page. So our website, what does it mean? That our website analyze this picture and using AI model that we have trained, and using the FAISS vector, they can similarize and check that whatever the images from the satellite database is similar to that, so that at that the highest accuracy that you can see that the same image of the same location can be of using the various sensor can be shown here. And these are the key capabilities at the glance that it is unified Earth representation, cross-modal search, AI-powered hunting, fast, scalable, travel, and actionable site. Now coming to the Prism cross-modal satellite intelligence flow diagram. So this is our the front page of our website that I have designed, going to show you in upcoming times. So this is our the first website portal where having the data of the SAR sensor, optical sensor, DEM sensor, and a multispectral sensor is present. So whenever user uploaded a picture of the SAR, optical DEM, or anything else, they can be analyzed on our trained model, that is JSON, radiometric calibration, geo registration, and the tailing. And after that, they will give the similarity between the images that is already present in the data training model. And after that, they will give the visualization and analysis that what does the picture that the user can upload it. So how is the temperature at there, how is the height, altitude, longitude at present at there, and what is the humidity, clouds, and everything that is going to be present. That is useful for the disaster monitoring, agricultural intelligence, environmental monitoring, urban development, and defense security. So these both are our website for. Now coming to the wireframe, that how our model is going to be trained. So these are the from where the data can be taken by the data set, and these can be trained using the model. And after that, each and a single uploadation, our model is going to be again and again retrained, so that it can be gives us the higher accuracy. And after that, at the final end, the visualization dashboard, user can get interactive GIS map, similar score, drive location, sensor comparison, download a score, and embedding visualization. It can be used by the user, analytics scientist, or the researcher for their further process. Now, coming to the architecture diagram that we have proposed, that we have the already in our data set and our the hardware component having the data of the SAR, optical, ISS, and the D. From that we grab it from the Unity portal, and we can put in our data training model of the Prism. That is the AI core model, and after that, they can give us a solution in the final dashboard. We have created the YouTube demo video that I am going to show you, and we have the repository, Git repository of the our source code that I have uploaded. I will see you and send you the link. And now coming to the technologies that we used in our solution. So for the front end, we use React Native, and the back end we use Python API and Unicorn. For deep learning, we use PyTorch, Chroma, and etc. For vector search, we use vector embedding, GPU indexing, and for the GeoS pattern, we use GDA, GeoPandas, and image for image processing, because it's mainly the selection and categorizing with the similarity between the images. So we use OpenCV, NumPy, Pillows, and all. For data engineering, we use pandas, arrows, skittler, and others. So these all things the technologies that we used. And now coming to the estimation of the cost, at how much it will be going to be costly. So as much as like possible, I utilize it that it will our project is going to be as at the minimum cost. So this is the cost of the proposed solution. Now coming to our website data hack design. So let us see, this is our website front page overview. So you can see that there is the home section where if any user come from the first time, then he can understand that how the our website can work, how can they will see and how can use this website. So first you upload AI processing, search database, and get the result. So this is the thing. And again, second is the second where we have added the main feature. So let us suppose you are from the Mumbai. So you are adding Mumbai and it's located. So then you will get the data from the Mumbai locality of the database map that what will be there, that base layer is loaded, road is visible or not, boundaries are mapped or not. So again, we let us see on the optical satellite data. What is the optical satellite source of the Mumbai? So Mumbai's optical satellite will show there that what is this is showing land cover mapping and all. And now similarly, we can see it from the DEM topography that how the Mumbai visuality from the DEM sensor is looking like. So it will be look like it, and also they will predict from our data prediction that how's the flood risk and how's the data type is data, what is the elevation and the height of that. And similarly, we have the SAR images that SAR image also so that how much the cloud cover, load visible or not, and everything. And the last one is the multispectral sim. So these also sees that how much the healthy crop is present there and the water stress level and the forest healthy layer. So this is the thing. Similarly, you can search from any other cities or any other localities. So these are the feature of our my website. And now coming to the method, that is the upload session. So let us suppose that if user is from any specific area and they will upload the from image that he where is he from. So first he let us suppose that he's from this locality area and we have submitted it. Then our AI model trained and so the data processing and the VIT feature extraction, and after that they will show there the result after some time. So this is our final submission, and after that, I'd like to thank for the issue and the team to give us the opportunity to show our the skills. So thank you, sir.